Okay, this is exam 1 from fall 2009. First question asks, in square centimeters, what is the area of this paper? Well, a typical piece of paper is about 20 centimeters by 30 centimeters, and 20 times 30 is equal to 600 square centimeters. So the answer is B. The standard unit of measure for the SI unit of time is based on which of these? The SI unit for time is based on the frequency of the cesium atom. Which of these equations is dimensionally correct? And I give what each of the variables means. So you just want to plug in the units for each. So m is mass, that's in kilograms. V squared, that's meters per second, so it's meters squared per second squared. And then you want to compare those units throughout. X is in meters, m is in kilograms, that's for mass, a is in meters per second squared. So far we're okay. We have kilogram meter squared per second squared, and then kilogram meter squared per second squared, minus pi, which has no units. M is in kilograms, x is in meters, so those don't match, so it's not 1. Then we have v squared, which is meters squared per second squared, is equal to meters squared per second squared, plus a, which is in meters per second squared, times x, which is in meters. So these all have units of meters squared per second squared, so that one's okay. We'll look at this next one. This is in meters minus meters per second times seconds, so the seconds cancel and give you meters, and that's equal to the acceleration, which is meters per second squared times time squared. So those cancel, that gives you all meters. So 3 is also an option, so the answer is E. Complete this arithmetic operation keeping proper sig figs. Remember, when you're adding numbers, you keep the lowest number of decimal places. When you're multiplying or dividing numbers, you keep the lowest number of sig figs. Well, here the lowest number of decimal places is just 1 decimal place, so that means that the answer is 325.5, keeping 1 decimal place, and that is B. Alright, this figure shows the position versus time for a particle. What is the position's average velocity from t equals 2 to t equals 7 seconds? Average velocity is x final minus x initial over your change in time. X final is at 7 seconds, that's minus 5. X initial is at 2 seconds, right there. So minus x initial, which is positive 10, divided by delta t, which is 7 minus 2. That's minus 15 over 5, that's minus 3. The answer is D. A plane lands an aircraft carrier with a speed of 70 meters per second. So our initial velocity is 70 meters per second. The plane's tail hook snags a cable, it slows the plane to rest in 2 seconds. So the final velocity is 0, and that occurs in a time of 2 seconds. Assume the plane undergoes constant acceleration, how far does it travel in this time? Well, to find the distance, we say x is equal to v0 t plus 1/2 at squared. Alright, and that's really what we want to find. We know v0, we know t, but we don't know a. So we also need to find the acceleration. And to do so, we say v final is equal to v0 plus at, and then we can solve this for a. So we say 0 is equal to 70 plus a times 2. So a is equal to minus 35 meters per second squared, and then we plug that in down here, so we have 70 times 2 plus 1/2 of minus 35 times 2 squared. That's 140 minus 70 is 70 meters. That's A. A car accelerates at a rate of 2 meters per second squared. What is this expressed in miles per hour squared? So 2 meters per second squared. And 1 mile, problem tells us there are 1609 meters, and then in 1 hour there are 3600 seconds. 60 seconds in a minute, 60 minutes in an hour. 60 times 60 is 3600. We square that to give a second squared, an hour squared, and that gives us 16,000 miles per hour squared. So that is option D. You throw a ball towards the ground, it bounces and returns to your hand. So you throw a ball down towards the ground, it comes on the ground and bounces and then goes back up again. Which of these plots best describes the motion of the ball from the moment you release it to the moment you catch it? Alright, so you release the ball right here, and it has a negative velocity. Alright, the negative velocity in the beginning, these, both B and D have positive velocity in the beginning because the velocity is on this part of the axis is positive. Alright, so it's neither B or D. It has to have negative velocity, and that could be either A or C. Has negative velocity. It comes down and turns around, and then it has positive velocity. So that gets rid of A. That only leaves C. So the ball drops down to the ground. It immediately goes from a negative to a positive velocity. That's in the bounce itself. And then as it comes back up, it slows down until it reaches your hand again. This graph shows the velocity versus time for a particle. What is the particle's instantaneous acceleration at t equal 70 seconds? To find the instantaneous acceleration from a v versus t graph, you just find the slope. So we'll find the slope, which is rise over run. The rise here is 30 minus 10 from the y-axis, and the run is 80 minus 60. That is 20 over 20. Rise over 1, and that gives us 1. But it's actually a negative 1 because this slope is negative. Actually, if I were to do this rigorously, this should be 10 minus 30, because 10 is my final state and 30 is my initial state, and that gives me a minus 20 over 20, which is negative 1. But you can also see just that the slope of this line is negative. Which of these statements represents the motion represented in this plot? The answer is increasing negative velocity. You want to look at the slope. The slope is negative, and the slope gradually increases, but it increases in the negative direction. Which of these is a scalar quantity? Well, mass is a scalar quantity, speed is a scalar quantity, and so is time and distance. So the answer is E. The following figure shows vectors A and B. What is the result of the sum of A plus B? You want to draw your vectors tip to tail. So I'm going to draw A first. That's my vector A. This is my vector B. And then the resultant vector looks like this. So that's this one, C. It's like you're walking somewhere, right? You can walk either this way or you can walk that way. It's the same, gives you the same final destination. Particle begins at the origin and travels 3.4 meters to the right. I like to draw a picture. 3.4 meters to the right. Then it moves 2.8 meters at 120 degrees. So 2.8 meters, like that. And then 1.2 meters down. So 1.2 meters down. Alright, I want to know what is the magnitude of the particle's displacement. I'm going to write the x and y components of these three vectors. This first vector has an x component in the positive direction of 3.4 meters. It has no y component. For the second vector, that is this one, the x component is 2.8 cosine of 120, and the y component is 2.8 sine of 120. When you put in the angle 120, and your x component is actually going to come out negative, right, as it should be, because you see the x component of this vector is pointing in that direction. And then finally the y component of the third vector, the x component of the third vector is 0, it's just moving down, and the y component is minus 1.2. It's negative because it's going in the negative y direction. Alright, you add these up. If you add up these numbers in the x column, that's 2, in the y column is 1.2, and then to find the magnitude, use the Pythagorean theorem, square root of 2 squared plus 1.2 squared, and that's equal to 2.3 meters. And that answer is D. If the vectors A plus B plus C and the magnitude of A plus magnitude of B is equal to the magnitude of C, how are the vectors A and B related to one another? Alright, if A plus B, let's say this is the vector A, this is the vector B, when you add them up, they're equal to C, when they're in the same direction like that. Alright, so that means that this is true and then this also is true. Now you can have it where you say A is in this direction and B is in that direction, and then C would be the sum of those, something that's much different. But the sum of the magnitudes, meaning that you add up the vectors in the same direction, would have a much different value. So in this case, they're pointing in the same direction. A. This figure shows the trajectories of 3 punts, each of which has the same initial velocity. What is the relationship between the angles of launch as measured from the x-axis for each trajectory? Let's see, the correct answer here is B. You can go by looking at how high they go up in the air. the punt A has the highest trajectory because the angle is really big, bigger than 45 degrees. Then B had the next highest, and then C had the smallest trajectory, an angle that is less than 45 degrees. Alright, so the answer is B. An archer shoots an arrow with an initial speed of 100 meters per second and an angle of 30 degrees from the horizontal. How high does the arrow travel? Draw a little picture here. The arrow travels something like this. We want to know what is the position, the y position, the height here. I know that my velocity in the y direction at this point is equal to 0. Now v0 is equal to 100 meters per second. It's given in the problem. v0 y then is 100 times the sine of the angle. The angle is 30 degrees. That's equal to 50 meters per second. V final y, the final being this state up here, is equal to 0. It comes to a rest in the y direction. Now I want to know what is the height. This is similar to what we did before with the, I think it was the airplane problem. We first want to find the time, and then we find the displacement. So Vfy equals V0y plus Ayt. So that is 0 equals 50 minus 9.8 is your acceleration times t, and then t works out to be 5.1 seconds. Then I want to know what my y displacement is. Y is equal to y0 plus v0yt plus 1/2 ayt squared. So y is equal to 0. v0 was 50 times 5.1 plus 1/2 minus 9.8, 5.1 squared. And that works out to be 128 meters. So 130 is the answer. Alright, a brick is thrown upward from the top of a building at an angle of 25 degrees to the horizontal and with an initial speed of 15 meters per second. If the brick is in flight for 3 seconds, what is the horizontal displacement of the brick? Alright, so you have this object follows a trajectory like this. We want to know what x is, and we're told that the time is 3 seconds, and x then is v0 x times t, and that's equal to your initial speed, which is 15, times the cosine of the angle, which is 25 degrees, times the time, which is 3 seconds. It's 41 meters. You drop a package from a plane flying at a constant speed. Without air resistance, the package will remain vertically under the plane while falling. This figure shows an elevator that is accelerating upward at 10 meters per second squared. What is the tension in the rope? 10 kilogram mass. I'm going to draw my vectors. This is the tension. This is the force weight. Apply Newton's second law. Sum of the forces equals ma. The tension minus the weight equals ma. Solve for the tension. That's force weight plus ma. The force weight is the mass, 10 kilograms, times 9.8. Plus the mass times acceleration, which is 10 kilograms times 10 meters per second squared. So that's 98 plus 100 is 200. Number 20, just supposed to pick out the equation that's right. This is going to be my x-axis. This is my y-axis. This is the angle theta. If I resolve those vectors for the force weight, this is my normal force. This is my upward force. This is force weight cosine of theta. And then this is force weight sine of theta. So let's look at these equations. F is equal to Fn. That's comparing these two. They aren't even on the same axis, so that doesn't work. Fn minus Fw equals ma. Might say that Fn minus Fw cosine theta is equal to ma, but that's not what it says. Fn minus Fw sine theta equals may. That would be correct if it was cosine theta, but that's not what it says. And then F minus Fw sine theta. F minus Fw sine theta equals 0. That is correct. as long as we assume that it is at rest, and that it says that the block is resting on it. So, I'm sorry. So, yes, that is okay. D is the answer. Okay, a dock worker loading crates on a ship finds that a 100-kilogram crate, initially at rest on the horizontal surface, requires a 400-newton horizontal force to set it in motion. However, after the crate is in motion, a horizontal force of 300 newtons is required to keep it moving with constant speed. What is the coefficient of static friction? Okay, the 400-newton force is the static frictional force. So we really just got to pick out those right numbers. Now, the static frictional force is equal to mu s, force normal. So 400 newtons is our static frictional force. We want to know what mu s. And then normal force is just the weight of the object. So the normal force is equal to mg. That's 100 times 9.8. Just write that in here. Times 9.8. And then we solve for mu s, and mu s is equal to 0.3. That's A. From rest, we step on the gas of our Ferrari, providing force F for 10 seconds, speeding it up to final speed V. If the applied force were twice the original force, how long would it have to be? Well, if we increase our force by a factor of 2, that increases our acceleration by a factor of 2. If we increase this by 2, the acceleration increases by 2. And if we increase our acceleration by 2, since we're starting from rest, this can just go to 0. If we increase our acceleration by a factor of 2, then our time goes down by a factor of a half. So initially it was 10 seconds, now it's going to be 5 seconds. So the answer is A. Mass sits on the bottom of an elevator that is in free fall. Which of these statements about the normal force on the block is true? If it's in free fall, the normal force is 0, but you can see this from Newton's second law. This is our normal force. This is our force weight. Fn minus Fw equals ma. Fn equals ma plus Fw. That is m times minus 9.8, that's your acceleration downwards, plus m times plus 9.8, which is g. And so that, of course, equals 0. Anti-lock brakes keep the car wheels from locking up when you stop your car. Why does this help slow the car down? Well, mu static is larger than mu kinetic. So C is correct, so static friction is better. Your wheels operate on static friction because that's better. Otherwise, we just slide around on skis all the time. Alright, the answer to this question is C, bubble C for this question.